Okay, welcome back to our coverage of exponents. So this is actually going to be the last concept that we're going to take a look at, especially for our particular grade. Well, here we just want to look at negative and zero exponents and what do we do when we are faced with these particular statements. Well, if you have a zero exponent, the key concept says for any non-zero number raised to the zero power, the answer is always 1. Always 1. And for a negative exponent, the key concept says for any non-zero number that is an integer. Hope you go back and understand what the term integer means. Whole number and their opposite. So if we've already excluded 0, so we're just looking at positive whole numbers, negative whole numbers. Okay. I just thought I'd back that up for you. We get the base or the reciprocal. We wanted to say we get the base over 1 and the negative power follows the base, but it becomes a positive. Again, we're just pretty much looking at the reciprocal. So let's take a look at a couple and make sure that we understand what we're talking about. Just a couple. So we'll start with an example that's dealing with negatives. Okay, well, no, let's do 0. And we'll just go back up here so you can make sure you understand. I know you do. So let's say non-zero number. Let's say we have 25 raised to the negative power. Backtrack. Say we have 25 raised to the 0 power. Then, according to our rule, any number raised to the 0 power equals 1. Let's try another one. Say if we have 642 raised to the 0 power. Again, rules say the answer is 1. Well, let's say we have a negative 15 raised to the 0 power. Again, the rules say our answer is 1. Want to look at one that's a little different from what we've just done. Say if we have a negative 2 times n to the 0 power. Pretty good number there. This is a little different. So notice that negative 2 is just to the first power and n is to the 0 power. So we can do that as negative 2 times n to the 0 power is 1. So now we're just looking at a negative 2 times 1, and the identity of multiplication says 1 times anything is anything. So we are left with a negative 2. Again, that's not bad. Not bad at all. You just have to make sure that you understand what you're doing and not get intimidated. Do not get intimidated at all. Okay. Let's take a look now at a couple, not many, maybe 3, maybe. Take a look at about 3 of the negative exponent and see exactly where they're going. So here, this example will be negative exponents. All right. Well, here's a good one. 7. 7 looks like I was trying to draw a T. 7 to the negative 2 power. Rule says any non-zero number, which 7 is, That is an integer. 7 is an integer raised to a negative power. We get the base, so let's take this base and put it underneath. And the integer, the actually power, is going to follow the base, but it's going to become positive. And since we're talking about the reciprocal of 7, then 1 will be your numerator. Let's look at another one. Now, I simply simplified. I did not evaluate this because we could go on realistically and evaluate this to 1 over 49 if we choose. If I say, but I don't choose, but I did anyway. Let's go with a negative 16 raised to the negative 4th power. Well, we're going to take the reciprocal of a negative 16. We didn't say we're going to change a negative 16 at all. So again, the reciprocal of a negative 16 is, believe it or not, a negative 16, well, 1 over a negative 16. And our negative 4 exponent is becoming a positive 4 exponent. So our answer is just simply 1 over a negative 16 to the 4th power. Okay, not bad so far. Let's take a look at, I like this one. We have 6 times 6 to the negative 6th power. Well, we got some multiplication in there, so we have to, before we can do anything, we got to deal with the multiplication. Here, 6 is the base. It says, and let's go ahead and make sure that we understand that base without a power, the power is 1, uno. So we have 6 to the 1st times 6 to the negative 6. So here we have to add these exponents. So that's going to be 1 plus a negative 6. I wonder if you still remember these rules of integers that says when the signs, and you're adding and the signs are opposite, that's a positive 1, that's a negative 6, you take the smallest absolute value, which is 1, and subtract it from the largest absolute value, which is 6, and you will have 6 to the 5th power, but you keep the sign of the larger, and it will be 6 to the negative 5th. Well, now we're going back to our negative exponent rule, which says your base, which is 6, goes in the denominator, and your exponent follows it. It's going to, but it becomes a positive, and since it's the reciprocal, we place 1 as the numerator. Okay, I want to just sneak 1 in, just somewhat sneak it. You know how you just sneak stuff. Let's just sneak it in. We have, and I know you're not gonna like me after this, but that's okay. Let's sneak 10a to the negative 3rd divided by a to the 4th. Oh my, oh my, oh my. What in the world are we going to do here? Well, it's simple. A to the 3rd, well, 10 is not. Let's keep that in mind. 10 stays. It's 10 to the 1st power. It's not, don't have a negative. But this A has a negative 3 for an exponent. So now we have a to the 4th on the bottom. So a to the 3rd comes down with it. So that's times a cubed, and there's our little 1 that stays in the denominator. Now we have multiplication, but multiplication is in the denominator. Well, it's the same concept. So we just have 10, and then let's put our 1, and then this is a4 plus 3, and we will come up with a final answer as 10 and 1 over a to the 7th power. I just thought I'd leave you with that one just to go Anyway, nice having you on rules of exponents. I will see you soon as we venture into rates and ratios and proportion. See you soon.